Hello everyone. Today we're going to attempt Ethernaut Level 14, which is Gatekeeper 2. So in this level, similar to the first Gatekeeper level, we have three gates, or rather three modifiers, which have certain required statements that we need to clear. And all of these three modifiers are applied to the enter function over here. And if all the three modifiers can pass, then it returns true, right? So let's get a new instance and let's see how we would solve this. Great. Now that we have the instance, we can go ahead and look at await contract.entrant, and currently it's set to the nil address. We need to set it to our address. So what I'm gonna do, I'm gonna copy paste this contract over into Remix, and from here we'll see what is actually happening. So let me zoom in a little bit, and then let's create our contract hack. So let's look at gate 1. Gate 1 is fairly easy. It just requires that message.sender is not equal to px.origin, which means, that we need to call the enter function from our smart contract, not directly through our MetaMask, so that these two values are not the same. That's fairly easy. Gate 2 is a little interesting. It uses inline assembly in Solidity, which gives the contract access to certain things that Solidity natively by itself cannot access. So specifically what's happening over here is we have a u and x, and within assembly code, we're saying that x is equal to the Xcode size of caller. Now, Xcode size is a Solidity assembly function which fetches the size of the smart contract code at a given address. And caller here is basically the same thing as message.sender. So we're basically setting x to the size of the contract code at message.sender. So how long is the contract code, right? The number of bytes. And we're requiring that x is equal to 0. Now this is interesting because our hack contract will call the Gatekeeper 2 contract, and hack will have a smart contract size greater than 0 because it has code, because it is a smart contract. But there's one edge case which is interesting, which is that Xcode size actually returns 0 if it is called during the constructor. So inside hack, we will have a constructor, and if we call like gatekeeper2.enter, which will then trigger gate 2 over here, Xcode size will actually return 0 because during the constructor's execution, technically the smart contract hasn't actually been created yet. And since it hasn't actually been created yet, Xcode size is still 0. So to bypass gate 2, this is a hint towards the fact that we need to call the enter function as part of the constructor of this contract. So that's the only way we're going to get past gate 2. In gate 3, we have this really long require statement, but if we look at it really simply, essentially what it's doing is there's some value over here, some uint64 value over here, which we are doing an XOR with this value over here, and we're saying that this is equal to this value over here. And now gate key is the thing we have to pass, and gate key is the thing we have control over. So we need to figure out the correct gate key. So this operation, if you're not familiar with this, the upper caret operation in Solidity is called the XOR, which stands for the exclusive OR. So, typically, the OR statements, it's like A or B. It's kind of like if any one of them is true, then it returns true, right? XOR is an exclusive OR, which means that exactly one of them must be true. So if you have like A XOR B, and then if A equals 1 and B equals 0, then A XOR B is equal to 1, right? Because exactly one of them is true. But if you have A equals 1, B equals 1, then A XOR B is actually 0. If this were a regular OR, this would also be true. But since it's an XOR, you want only exactly one of them to be true. So this is now 0. So with that in mind, we come up with an interesting property in XORs that if A XOR B equals C, then this also implies that A XOR C equals B. And you can test this out very easily. You can say that if 1 XOR 1 equals 0, that means 1 XOR 0 equals 1, right? You can substitute all the different values and see that this statement is true. But they have the property that A XOR B equals C will imply that A XOR C equals B. So this is kind of a statement of that format. This is A XOR B equals C. So to calculate B, we just need to move this over here and we can do A XOR C equals B, right? So what does that look like? That means that this whole thing, this whole number, XORed with type uint64.max is equal to uint64 gate key. But we need gate key as a byte state value, so then we'll just wrap a byte state type conversion around this whole thing. So wrap this full XOR expression around a byte state, and we end up with a byte state of uint64 gate key. So this is the gate key that we need to pass to bypass gate 3. And at this point, we've cleared all the gates. So gate 1, call it through a smart contract. Gate 2, call it during the constructor. And gate 3, calculate the gate key using this method. So now we're all set. What we need to do is I will take the contract address, await contract.address, and we'll take this contract address and I'll say that this is a gatekeeper contract. So we'll say Gatekeeper 2 contract equals Gatekeeper 2 at this address. Gatekeeper contract equals Gatekeeper 2 at this address. Then we define the gates key. So the gate key is just a byte state value. Gate key is equal to this whole expression over here, right? The one thing to change, however, is this evi.encode packed message.sender, because in the gatekeeper contract, it's expecting message.sender, but when we're calculating it on our side, message.sender is actually this, as it's the address of this contract, right? And since it's the address of this contract, actually, this needs to be address of this. And once we have the gate key, now we can just call gatekeeper contract.enter with the gate key, and I'll compile this, and we'll deploy the hack contract to the network, hit confirm, wait for that to go through. And now that that has gone through, go back to Ethernaut, and we'll check await contract.entrant, and this is no longer the null address. So now we can submit the instance, hit confirm, and there we have it. Completed this level. Thanks for watching, and I'll see you in the next one, who's going to be Notcoin.